Have you ever wondered what if the Earth was actually flat? Dive deep into the annals of history, and you'll stumble upon an era when humanity held a rather unconventional belief about our planet's shape. Yes, we're talking about the flat Earth theory. This theory, as old as civilization itself, proposes that Earth is not a sphere but a flat disk, surrounded by an impenetrable wall of ice. The ancient cultures of Greece, Egypt, and China all harbored this belief. It was the pre-Socratic philosophers who first suggested a spherical Earth, a radical idea at that time. However, the flat Earth theory was not completely abandoned. It found its proponents throughout history, from the early Christian church fathers to the modern flat Earth societies. The core belief of this theory is that Earth is a flat disk with the Arctic Circle in the center and a 150-foot-tall wall of ice known as Antarctica at the rim. This ice wall allegedly holds the oceans back like the walls of a giant bowl. Above this disk, the sun, moon, and stars move in circular paths, and their apparent rising and setting are merely an optical illusion. This theory is fortified by various arguments, many of which revolve around the interpretation of perspective and the behavior of light and shadow. For instance, proponents often assert that the horizon looks flat, not curved, to the naked eye. Or that the way ships disappear over the horizon is due to perspective, not the curvature of the Earth. Modern flat Earth societies continue to keep this theory alive, advocating a literal interpretation of certain biblical passages and rejecting centuries of scientific discovery. They challenge the mainstream scientific consensus, posing questions that they believe traditional science fails to answer satisfactorily. But, as intriguing as it sounds, how does the flat Earth theory explain certain phenomena like gravity, day and night, or the movement of celestial bodies? Flat Earthers have their arguments, some of which can be quite compelling. One of the most famous experiments, the Bedford level experiment, was conducted in the 19th century by a man named Samuel Rowbotham. He claimed that the natural physics of water to find its level was evidence that the Earth is flat. He tested this by observing a boat sailing away on a 6-mile stretch of still water. According to him, if the Earth was curved, the boat should disappear from sight, but it didn't. Hence, he concluded that the Earth must be flat. Then, there's the conspiracy theory. Many flat earthers believe that there's a vast global conspiracy to hide the truth about the Earth's shape. They argue that space agencies like NASA and other governmental bodies manipulate photographs and data to maintain the illusion of a spherical Earth. This, they state, is done for reasons ranging from control to profit. Biblical interpretations also play a part in some flat Earth arguments. Some proponents of the flat Earth theory interpret certain passages from the Bible as suggesting that the Earth is flat. For instance, they cite passages which speak of the 4 corners of the Earth or the circle of the Earth as evidence of a flat Earth. Furthermore, flat earthers often question why we don't feel the Earth's rotation if it's spinning at over 1,000 miles per hour. They argue that this lack of perceptible movement is more consistent with a stationary flat Earth than a rotating spherical one. Lastly, flat earthers point to the horizon. They argue that the horizon always appears perfectly flat to the naked eye, no matter how high you go. According to them, this would be impossible if the Earth was spherical, as the curve of the Earth would become increasingly apparent as one ascends. Yet, despite these arguments, there are countless pieces of evidence that suggest we live on a spherical planet. Long before we had satellites and space travel, ancient scholars already deduced that we live on a sphere. The idea that the Earth is spherical, not flat, has a long and fascinating history. This belief, commonly referred to as the Spherical Earth theory, has been around for thousands of years, and key proponents of this theory have included some of the greatest minds in history, such as Pythagoras, Plato, and Aristotle. The Spherical Earth theory is rooted in a number of core aspects. One of the most fundamental of these is the concept of gravity. The force of gravity pulls everything towards the center of mass, and for a large solid object like the Earth, that pull shapes it into a sphere. Another cornerstone of the Spherical Earth theory is the observation of Earth's shadow during a lunar eclipse. When the Earth passes between the Sun and the Moon, it casts a round shadow on the Moon. This shadow is circular regardless of the angle at which the shadow is cast, indicating that the Earth is spherical. And let's not forget the photographic evidence from space. Since the mid-20th century, we've been able to send satellites and astronauts into space who've captured images showing Earth as a round object. These photos provide some of the most compelling evidence for the Spherical Earth theory. But the Spherical Earth theory isn't just about physical evidence. it's also about the way this idea has shaped our understanding of the world and our place in it. It's about the explorers who set out to chart unknown territories, the scientists who dared to challenge accepted beliefs, and the innovators who used this knowledge to make incredible advancements in technology and space exploration. In essence, the spherical Earth theory is more than just a theory. It's a testament to human curiosity and the relentless pursuit of knowledge. It's a reminder of how far we've come in our understanding of the universe and our place within it. The spherical Earth theory isn't just a theory, it's a scientifically supported fact. The evidence for a spherical Earth is overwhelming and comes from many different scientific disciplines. Let's start with geography. The phenomenon of time zones is a clear indicator of a spherical Earth. If the Earth were flat, we wouldn't experience different time zones. Yet, when it's midday in New York, it's already evening in London, and dawn is breaking in Sydney. This is because as the Earth rotates, different parts of the world are exposed to the sun at different times. Next, let's take a look at astronomy. Ever notice how different constellations are visible in the night sky depending on where you are in the world? This is due to the curvature of the Earth. Our planet's curve changes our view of the stars. For instance, the North Star, Polaris, is only visible from the northern hemisphere. If the Earth were flat, we'd be able to see the same stars from anywhere on Earth. Physics also provides compelling evidence. The force of gravity, which pulls everything towards the center of mass, is consistent with a spherical Earth. On a flat Earth, gravity would pull everything towards the center and cause an uneven distribution of weight. But on a sphere, gravity pulls everything towards the center, resulting in a uniform distribution of weight and a stable planet. Finally, we have satellite imagery. Pictures from space clearly show a round spherical Earth. Astronauts, satellite images, and even live feeds from the International Space Station all confirm the Earth's roundness. If the Earth were flat, these images would look very different. In conclusion, evidence from geography, astronomy, physics, and satellite imagery all strongly support the theory that the Earth is spherical. These arguments are backed by rigorous science and countless observations. While the flat Earth theory may be an interesting thought experiment, the evidence overwhelmingly supports the idea that we live on a sphere. So is the Earth flat or spherical? The answer depends on who you ask. Just as a coin has two sides, so does the debate about the shape of our planet. We've delved into both the flat Earth theory and the spherical Earth theory, each with its own set of arguments and proponents. The question now is, where does the truth lie? In our journey, we've explored the flat Earth theory, an idea that harks back to ancient cultures and still has its advocates today. Proponents of this theory argue that the Earth is a flat disk with the North Pole at its center and a massive wall of ice surrounding the edges. They question the validity of photos from space and the physics of a spinning globe. On the other hand, we've also examined the spherical Earth theory, which is backed by centuries of scientific research and observation. Supporters of this theory point to evidence like the curvature of the Earth as seen from high altitudes, the way ships disappear over the horizon, and the images captured by satellites orbiting our planet. It's crucial to remember that questioning is the heart of scientific inquiry. It's what drives us to explore, learn, and push the boundaries of our understanding. At the same time, it's equally important to acknowledge the weight of evidence and consensus in the scientific community. While it's true that the flat Earth theory has its followers, the overwhelming scientific consensus supports the spherical Earth theory. This consensus isn't based on blind faith, but on a wealth of empirical evidence gathered over millennia, from the times of the ancient Greeks to our present spacefaring age. In the final analysis, the shape of our planet isn't something that changes based on individual perspective or belief. It's a matter of scientific fact, established through rigorous research and observation. In the end, the shape of our planet is a matter of scientific truth, not personal belief. For now, the Earth remains a beautiful sphere spinning in the vastness of space.